Welcome, ladies and gentlemen, to this video lecture. Let's take a look at this example. So we want to compute this integral, and we see that it is the product of two functions. Let us use our tool, integration by parts, again to compute this integral. So we see here we've got an x squared, and here we've got a sine x. And if we transfer one of these, or if we view sine x as a derivative of minus cosine x, and we transfer one of those derivatives to the other term, then this other term will become simpler. It will become 6 times x. And then let's see what happens. Okay, so let us view this as the derivative of g and this as f. Okay, then our integral becomes, actually before we do that, let us define f of x as 3x squared and g prime of x as sine of x. Then we've got f prime of x is 6x and g of x is equal to minus 6 cosine x. Then let's take a look at what happens to our integral. Our integral is the integral from 0 to pi over 6 f of x g prime of x dx. This is the same as f of x g of x from 0 to pi over 6 minus the integral from 0 to pi over 6, and now with our derivative transferred to the other function. So this becomes 6x minus cosine x dx. And this minus, I'm going to use that to make this sign in front a plus. Okay. So now let us substitute our f and g back in there. That becomes 3x squared cosine minus cosine x. So like so, 0 to pi over 6 plus integral from 0 to pi over 6, 6x cosine x dx. Okay, so this term is fine. Here we've got a problem. We can't evaluate this yet, but we see again we've got a product of two functions, and lo and behold, look here, this function 6x, if we transfer a derivative to the 6x, if we take the derivative of 6x, then that is just going to become 6. So that is simpler. So what we will do now is we will apply integration by parts again to this term. So let's set u of x. So think about what needs to happen. This needs to be, we want to transfer a derivative from this function to that function. So u of x, we're going to make 6x, and the derivative of v of x, we're going to have set that as cosine of x. Then the derivative of u of x, that is just going to be 6, and v of x then needs to be sine x, because the derivative of sine is cosine. And now let's just think about we're just going to take this term, so the integral from 0 to pi over 6x cosine x dx. What is that? That is the integral from 0 to pi over 6 of ux v derivative x dx. That becomes ux vx evaluated between 0 to pi over 6 minus the integral from 0 to pi over 6, and now with this derivative passed to the u, so the ux vx dx. And now let's substitute what we have in there. This then becomes 6x, and v is sine x, evaluated between 0 and pi over 6, minus integral from 0 to pi over 6. That becomes u prime is 6, and v of x is sine x dx. Okay, and this we can evaluate. This then becomes 6x sine x from 0 to pi over 6, and this becomes plus 6 cosine x between 0 and pi over 6. And you can go substitute everything in there. What I get is pi over 2 plus 3 times square root 3 minus 6. So this term is this expression that we just had. And if we go substitute what we have in there, what we then get is our original integral is minus square root 3 pi squared over 24 plus pi over 2 plus 3 square root 3 minus 6. So I would suggest, as an exercise, you go confirm that our integral is equal to that. Okay, so that is it for this example. And notice here we applied integration by parts twice. So sometimes you need to apply integration by parts twice. Okay, that is it for this example. I will see you in the next one.